Topic 4 is mainly Chapter 4, which is Properties of Matter. We're going to do a little bit of a chemistry review and then go into how glass is analyzed. So first thing is determining what's a physical property and what's a chemical property. Physical properties are weight, volume, color, boiling point, melting point, different sorts of characteristics that can just be measured without making them trying to make them combine with another substance or whatever. They're just standalone properties. As opposed to chemical properties that describe the behavior of a substance when it reacts or combines with another substance. So, is it corrosive? So does it break other things down? Is it flammable? Those are some examples of chemical properties. When we were in chemistry and physics classes, you talked a lot about the metric system, to a lesser extent in biology. But the main ones we're going to be looking at are length, mass, and volume. And those are meter, gram, and liter. Those are the base units of measurement for those. So notice there aren't any prefixes with those. If you add prefixes, then those units become bigger or smaller. The definition of matter is anything that has mass and occupies space. There are 3 different states of matter here on Earth. Solids have a definite shape and volume. Liquids have a specific volume, but they take the shape of the container. And gases have neither a definite shape nor volume. Substances can change from one phase to another without forming a new chemical species. It's just going from one physical state to another. This is called different phases of matter: solid, liquid, gas. In addition to the base units of metric measurement, we're going to need to know a little bit about light too when we're analyzing glass. So visible light ranges from red to violet in the electromagnetic spectrum. So if we look right here, this is the visible light spectrum. You see the wavelength. Short wavelength is down towards the left, long wavelength is towards the right. And then notice that energy increases as you move towards the left. So if we're talking about visible light, down here, violet has the highest energy and the shortest wavelength. Violet is the color of visible light that has the highest energy and the shortest wavelength. Some other physical properties we're going to be taking a look at. Temperature, we already did that. Weight is the force with which gravity attracts a body. Mass is the amount of matter an object contains independent of gravity. We're going to need mass and volume to measure density. Density is mass divided by volume. It can be a characteristic property of a substance. It can aid in identification. So, in other words, it remains the same regardless of sample size. Density of a type of matter, specific substance, remains the same regardless of size, and so it can be used to identify that substance. We're going to use density to identify different types of glass. This is a little bit of background we also need to know, back to the light waves. They travel at a constant velocity in air until they go to another medium. When they go to another medium like glass or water, they're slowed down, and that causes those rays to bend. The bending of light waves is called refraction. And refractive index is another way we're going to analyze glass. By definition, it's the ratio of the velocity of light in a vacuum to that in the medium under examination, so whether it's water or glass. And a vacuum, just in case you're not sure, a vacuum is a chamber with no air. The refractive index of water at room temperature is 1.333, meaning that light travels 1.333 times faster in a vacuum than it does in water. Refractive index is also able to be used to characterize or identify a substance. Now let's talk about glass. Glass is made of sand. Fancy term for that is silicon oxides. And depending on the type of glass, there are different metal oxides that it's combined with to change its color, change different characteristics about it. Tempered glass is stronger than normal glass due to rapid heating and cooling. Tempered glass is used in large glass panes that have a high potential to break, such as basketball backboards, patio tables, sliding glass doors. Laminated glass is found in car windshields, so just the front window. Laminated glass has plastic sandwiched between two pieces of ordinary glass. This is done because the glass sticks to the plastic and actually prevents that glass from flying around. If it breaks, it doesn't shatter and fly around, so it reduces the chances for injury of the occupants of the car. Heat-resistant glass has a compound called boron oxide that's added to it. Heat-resistant glass is found in light bulbs, like headlights of cars, glass cookware in the kitchen, chemical glassware in a laboratory. Glass types will have class characteristics, but then they will cross over as glass fragments into individual characteristics if they're able to be pieced together. When a forensic scientist is looking at glass fragments, there are two physical properties that they're going to be looking at: density and refractive index. The flotation method is used to compare glass densities. A glass particle is immersed in a liquid, and then that density of the liquid is carefully adjusted until the glass chip remains suspended in the liquid medium. When it's suspended in that liquid, it has the same density and can be compared to other relevant pieces of glass, which will remain suspended like that one, sink or float. This is called a density column analysis. So two pieces of glass from the same source will do the same thing in that density column. The immersion method is a little bit different. Here we're looking at refractive index. We're putting a glass particle in a liquid medium whose refractive index is varied until it's equal to that of the glass particle. So here we're measuring refractive index. The match point is called the Beck line, and that disappears and minimum contrast between liquid and particle is observed. It's a bright halo near the border of a particle that's immersed in a liquid of a different refractive index. You can see the Beck line in your textbook. It's probably the best place to see it. The penetration of window glass can also be analyzed. Some kind of a projectile, a bullet or a stone, can produce cracks which radiate outward. They're radial fractures, and then they encircle the hole, concentric fractures as well. By analyzing these, the forensic scientists can determine the direction of impact and also, in this case, which bullet hole was created first. So what we're looking at here is these shatter lines here. And you can see that these shatter lines are stopped by these shatter lines. So in other words, this bullet hole on the left was made before this bullet hole on the right. A high velocity projectile, like a bullet, will leave a hole that's wider on the exit side. That's interesting to know. The direction of impact can also be accomplished by remembering the 3R rule. Radial cracks form a right angle on the reverse side of the force. We'll take a look at that in lab. The sequence of impacts, like I said on the previous slide, is possible to determine because a fracture always terminates at an existing line of fracture. Even if the remotest possibility exists that glass can be pieced together, every effort must be made to collect all the glass found. When there's an individual fit that's thought to be improbable, either way, the evidence collector has to submit all glass evidence along with a representative sample of broken glass remaining at the crime scene. So glass evidence found in possession of the suspect along with a standard reference or a representative sample from the glass at the crime scene. Glass fragments should be packaged in solid containers to avoid further breakage. If shoes or clothing have glass fragments, they should be individually wrapped in paper and sent to the lab.